So our next part is y is equal to square root x plus square root of x. We have to differentiate dy by dx by using chain rule or by using substitution method. So as given that y is equal to square root x plus square root of x, let t is equal to x plus square root of x. So this is actually t. So our y will become y is equal to t square root, which can be written as t raised to the power 1 by 2. Now again the same thing which is discussed in question 1, we have to calculate actually dy by dx as y is a function of x. So dy by dx, which we have to find, but now by using substitution this whole function will become t. So now t is actually will become a function of x. So from this expression we have to calculate dt by dx, and by using substitution that y will become t raised to the power 1 by 2. So y will become a function of t. Then when we want to change or we want to differentiate this y, so that is actually y with respect to t will become dy by dt. So by using these two differential or these two derivatives, we will form dy by dx. So now we start our process. So differentiate t with respect to x first. Dt by dx, this x, when we apply derivative, that will become 1, and when we apply derivative on square root of x, that is 1 by 2 x raised to the power minus 1 by 2 by using power theorem, that can be written as 1 plus 1 by 2. This will shift it into the denominator and that will become square root of x. So finally we have dt by dx is equal to 1 plus 1 by 2 square root of x. Now as y is equal to t raised to the power, this is actually t raised to the power 1 by 2, not negative 1 by 2. So this is actually y is equal to t raised to the power 1 by 2. Now we have to calculate a derivative of y with respect to t. So differentiate y with respect to t by using our power theorem, that will become dy by dt, and on right hand side that is 1 by 2 t raised to the power 1 by 2 minus 1, which is actually minus 1 by 2. So dy by dt is 1 by 2. By shifting it to the denominator, this is actually first 1 by 2 t raised to the power 1 by 2, and that can be written as in the form of square root. So dy by dt is actually 1 by 2 square root of t. Now we already calculated these two derivatives, dy by dt, which is this one, and dt by dx, which is this one. So joining these two derivatives or by forming chain of derivatives, that is actually by using chain rule. So dy by dx is equal to dy by dt into dt by dx. By substituting the values of dy by dt and dt by dx, that will become 1 by 2 square root of t into the value of dt by dx is 1 plus 1 by 2 square root of x. Now we substitute the value of t, that is 1 over 2 square root of x plus square root of x, and this is by taking LCM, that will form 2 square root of x. This is 2 square root of x plus that will be cancelled out, so we have just 1. And finally we have our required result, which is dy by dx is equal to 2 square root of x plus 1, and in the denominator this 2 will be multiplied by 2, will become 4 square root of x into square root of x plus square root of x, which is our required result. So the next part is y is equal to x into square root a plus x a minus x. Solution, given that y is equal to x into a plus x divided by a minus x. As we can see, our first two parts, that there was a single function which is in the power, but here we have two parts, x and this whole thing. So we can form a single function by entering this x into this power. So when we shifted this x into this power, so that will become square of x, and now multiply by a plus x, that will become ax square, plus when x square is multiplied by x, then that is actually x cube, and the denominator will be as it is. So now y will modify, or y will reshape into the function like ax square plus x cube a minus x, and we can easily substitute this inner function in the form of t, and then y will become t square root of x. So let t is equal to ax square plus x cube divided by a minus x, and hence y will become t raised to the power 1 by 2, because this whole portion is substituted in the form of t. So y will become t raised to the power 1 by 2. Now first we differentiate t with respect to x. From here we have to calculate dt by dx, and then from here we will calculate dy by dt, and by joining these two variables by using chain rule, we will calculate dy by dx, which is our required result. Now dt by dx, by applying derivative on right hand side of this value of t, ax square plus x cube divided by a minus x. Again by using our quotient theorem, a minus x whole square, and this a minus x will be as it is. Derivative will apply on numerator function, which is ax square plus x cube, minus ax square plus x cube will be as it is, and derivative will apply on our denominator function, which is a minus x. So when we apply derivative on this part, derivative will apply separately on these two terms. So first derivative will apply on ax square, and this is of the form actually c f of x. C will come out from the derivative, and derivative will apply only on the variable function, which is x square, and that is 2x. By multiplying a, that will become 2ax, plus then derivative will apply on x cube, which is 3x square, and this a minus x will be as it is, minus this ax square plus x cube will be as it is, and derivative will apply on a minus x. A is the constant term, so derivative will become 0, and derivative of minus x will be minus 1. Now we simplify this step, that will become 2ax into a, 2a square x minus 2ax square plus 3ax square minus 3x cube, which is actually the product of these two terms. Simply we have to multiply these two terms. This minus and this minus will become plus, and we have ax square plus x cube. So by simplifying, we will get dt by dx, which is 2a square x plus 2ax square minus 2x cube divided by a minus x whole square. By taking common 2x, this will become a square plus ax minus x square. This denominator will be as it is, a minus x whole square. As y was equal to t raised to the power 1 by 2. Here we have calculated our dt by dx. Now we will start to calculate dy by dt. So we will start our procedure by using y is equal to t raised to the power 1 by 2. Then differentiate y with respect to t, as y is the function of t. So just calculate the change in y with respect to t. dy by dt, that will become, by using our power theorem, 1 by 2 t raised to the power 1 by 2 minus 1, which is minus 1 by 2. And again that is actually 1 over 2 t raised to the power 1 by 2, and this 1 by 2 can be written as square root of t. So this is our finally dy by dt. By using our chain rule, this is dy by dx, and that will be equal to dy by dt and dt by dx. We already calculated these two derivatives. Dy by dt is 1 over 2 square root of t into dt by dx is this one, 2x a square plus ax minus x square divided by a minus x whole square. Now we apply the value of t. This 2 will be cancelled out, and by substituting the value of t, which is ax square plus x cube divided by a minus x, into this is exactly the same thing from our previous step. So this is of the form 1 over ax square plus x cube raised to the power 1 by 2, and a minus x is also with power 1 by 2, but when we shift it into the numerator, that will become a minus x raised to the power minus 1 by 2, and this is exactly the same thing. So again, substituting the values, that will become exactly the previous step was ax square plus x cube raised to the power 1 by 2 a minus x. This numerator will be as it is, x into a square plus x ax minus x square, and in denominator we can take x square as a common factor from these two terms, and when we take a common x square from this expression, this 1 by 2 will also apply to the x square, so that will be actually of the form this x square is the common factor, and with this power 1 by 2, so we have only in power 1 by 2 or in square root a. This x square is the common thing, so that is actually come out from this power 1 by 2. We have only a plus, and from here x cube will become x by taking common x square, and here we have a minus x, and this a minus x is actually the same base, so we can join these two powers 2 minus 1 by 2. This 2 will be cancelled out, so we have only this x, and which is cancel out to this x, so the numerator will be as it is a square plus ax minus x square, and in denominator that will be a plus x square root into a minus x. 2 minus 1 by 2 will become 3 by 2. So this is actually our final result, dy by dx. Next we move on part number 4. Y is equal to 3x square minus 2x plus 7 raised to the power 6. Solution: given that y is equal to 3x square minus 2x plus 7, again using the same substitution technique, we substitute this inner function in form of t. So that is actually, let t is equal to 3x square minus 2x plus 7. So then y is equal to t raised to the power 6. As we substituted this whole function in the form of t, so y will become t raised to the power 6. Again using the same process, we actually find dy by dx from this expression, but we split it into the function. First t is equal to 3x square minus 2x plus 7, so from here we calculate dt by dx, and then y is the function of t, so from here we will calculate dy by dt. So first we differentiate t with respect to x, applying derivative on this function dt by dx. When we apply derivative on right hand side, so by using some theorem, derivative will apply separately on these three terms, so that will become 3 as it is, and by applying derivative on x square, that will of the form 2x minus 2 is the constant term, so derivative will apply on x, which is 1, and derivative of a constant function which is 7, so that is 0. So finally derivative of t with respect to x, or dt by dx, will become 6x minus 2. As y was equal to t raised to the power 6, so when we apply derivative of y with respect to t, so differentiate y with respect to t, this will become dy by dt, and by using power theorem, this will become 6 into t raised to the power 6 minus 1, which will become 5. Using chain rule, dy by dx is equal to dy by dt into dt by dx. Now substituting the values of dy by dt and dt by dx, dy by dt is actually 65, which is this one, into dt by dx, which is 6x minus 2. So put these values in this expression. So finally dy by dx will become 65 into 6x minus 2. Then we substitute again the value of t, which is actually 3x square minus 2x plus 7 raised to the power 5 will be as it is, and this 6x minus 2, by taking 2 as a common factor, this will of the form 3x minus 1. So this 6 will be multiplied by 2 will become 12, and 3x square minus 2x plus 7 raised to the power 5 into 3x minus 1, which is our required dy by dx of this question. Part 5. To calculate derivative of this function by using substitution technique. Given that y is equal to a square plus x square, a square minus x square, again exactly the same procedure by substituting this inner layer or inner function in form of t, then that is actually t is equal to a square plus x square, a square minus x square, and y will become t raised to the power 1 by 2. I think this one is an easy exercise for you people, so you must solve this question for yourself. I just explain very simply. This is our quotient theorem. You must check this yourself of this part. Just simplify this one. So finally dt by dx in the previous slide, and now as y is equal to t raised to power 1 by 2, we already calculated in different parts derivative of y with respect to t. This will of the form 1 over 2 square root of t. So this is finally our dy by dt, and dt by dx we calculated in the previous slide. So using chain rule, dy by dx and dy by dt into dt by dx, substituting the values of these two derivatives, this will of the form 1 over 2 square root t dt by dx we calculated. That is 4a square x divided by a square minus x square whole square. Again replace the value of t, which is a square plus x square, a square minus x square. This one exactly the same as we see in the previous step. This 2 will be cancelled out to this 4, that will become 2, which is this one, a square x, and a square minus x square is as it is. We can separate it out, a square plus x square with power 1 by 2, and a square minus x square, when we shift it into the numerator, that will of the form minus 1 by 2. So now these a square minus x square and this a square minus x square is the common base, so we can join the power of these two terms, which is 2 and minus 1 by 2. So just simplify this one, that is actually 2a square x square root a square plus x square, and by joining a square minus x square, this one is actually minus x square. So 2a square x square root a square plus x square and a square minus x square will become 2 minus 1 by 2 is 3 by 2. So this is actually our required dy by dx.